Hi, Math 30-1. Today we're going to be starting our next chapter, Polynomial Functions and Equations. I'm going to go through lesson 1 with you, so polynomial functions. So this is just going to be kind of a quick review of what defines what a polynomial is and some special terms associated with that. So in your workbooks, this is on page 287. Okay, so we're going to be using eventually long and synthetic division to divide polynomial expressions by binomials and use these processes as a means to factor a polynomial and to determine zeros of a polynomial function. We'll also establish a relationship between equations of polynomial functions and their graphs. So just in terms of what a polynomial function is, it's of this form. So there we go, f of x. So where a0, a1, a2, an are real numbers, and an can't be 0, and n is an element of whole numbers. So what those values are, so a1, 2, etc. are called our coefficients. The coefficient of the highest power of x is called the lead coefficient. So we take a look at our polynomial, whatever the highest power is, the number in front of that is called our lead coefficient. The term typically found at the end with no x value or no variable is called our constant term. And then the value of n is the degree. So we take a look at our polynomial. The highest exponent is our degree. So all of these terms you have heard before. Okay, so class example 1. Consider this polynomial here. So state the degree of the polynomial. So you take a look at all those exponents, and we notice that the highest one is 4. So this is a 4th degree polynomial. Then we look at that same term, and we take a look at the coefficient with it. So it has a lead coefficient of 1. And constant term is the term at the back with no variable. So in this case, the constant is 5. Okay, so just recognizing if a function is a polynomial. So expressions containing roots of variables, negative or fractional powers of a variable, or any coefficient which is a non-real are not polynomial functions. So we're just going to state whether or not these are polynomial functions. If they're not, well, we're going to explain why. So taking a look at a, f of x here, so we notice that it has an exponent, a rational exponent here, so this would not be a polynomial. And the reason being is because of this exponent here. For b, taking a look at, so the coefficients are fine, then we look at the exponents. We notice here we have a negative exponent, so they have to be whole number exponents. So again, this is not a polynomial, just simply because of that exponent. Okay, then if we take a look at C, so our exponents are all good, our coefficients are good, so yes, this would be a polynomial. And then if we look at D, so coefficients are fine, but we have a problem right here with this term. So this would be root 5 and root x cubed. So because of this term again, this makes this not a polynomial because it has a rational exponent. Exponent has to be a whole number. Okay, and then with E, this one would be a polynomial, and if I look at this term, this is the same as root 3, and the square root of x squared is just x. So the root and the squared cancel out, so yes, this is a polynomial. Okay, and then the last one here, this would not be a polynomial because can you take the square root of a negative number? No, so not a polynomial. That is not a real number. Okay, so just a quick review, identifying polynomials. Okay, so taking a look at degree, lead coefficient, and constant. So sometimes a polynomial function can be in a disguised form. So state the degree, lead coefficient, and the constant term of the following. So if I take a look at f of x here, notice that it's not in descending powers. So we just have to just make sure you recognize that. So the degree is the highest exponent. In this case, this is 3. The coefficient with that exponent, so our lead would be negative 25. And the constant has no variable, so in this case, negative 39. And then with b, we would have to do some FOILing here in order to determine the degree. So if I multiply two binomials together, I will have a degree of 2, highest exponent. Our lead coefficient would be those first terms multiplied together. So in this case, the lead coefficient would be 10. And our constant is going to be the last term of our FOILing, which in this case would be negative 7. So you could expand this out and write it down. You'd have it beside you. Okay, this one here, same type of thing. So in the following polynomials, determine the degree, lead coefficient, and the constant without expanding. Verify the results in part 1 by expanding and simplifying the polynomial. Okay, so this one here, in order to determine the degree, well, we notice we have a binomial that's being squared. And then we also would be multiplying that by that trinomial there. So our degree would be, we're going to go x is going to be squared, and then we're still going to multiply that by another x squared, which makes it x4. So our degree would be 4. Okay, then to get our lead coefficient, we would have to go 3, so that binomial has to be squared. It has to be multiplied by that 2 in the front, and then all of that has to be multiplied by 5 in that trinomial. So 3 squared is 9, times 2 times 5, which means the lead coefficient would be 90. And then for our constant, so within that binomial, we would take negative 1 and square it for our FOILing. Then we would times it by 2, and then we would have to multiply it by the constant in the trinomial, which is 1. So our constant term would be 2. Okay, so then they ask us to actually expand this out. So we'll have 2. If we FOIL that binomial there really quick, we'd have 9x squared minus 6x plus 1, and multiplied by the trinomial, 5x squared minus x plus 1. Okay, then you could distribute, or you could multiply your two trinomials together, and once you've collected like terms, you'd get 45 x4 minus 39x cubed plus 20 x squared minus 7x plus 1. And then lastly, distributing that 2 to all of our terms makes it 90 x4 minus 78x cubed plus 40x squared minus 14x plus 2. So lots of work in terms of expanding it. So if you're able to simplify it like we did, it might be a lot easier. Okay, same thing with part B to determine the degree. So our degree for this one, we would have to go x and square it. And this time it's being added, so our highest exponent will just be squared. And then for our lead coefficient, so we're going to go 3 and square it, and then times it by 2. And then we're going to be adding it. So the like terms would be that 5, which makes our lead 23. And then for the constant, we're going to go negative 1 and square it for that binomial, times it by 2, and then like terms with that trinomial, which will be the 1, which makes it 3. Okay, and then same type of things if I was to expand this, so it would be 2 that binomial squared, 9x squared minus 6x plus 1. And we're adding it to 5x squared minus x plus 1. Distribute the 2 in here, 18x squared minus 12x plus 2 plus that trinomial, 5x squared minus x plus 1. And then for our like terms, we've got 23x squared minus 13x plus 3. So either method works, expanding it or just really quickly going through. Okay, class example 5. Consider the polynomial function p of x equal to 7. So explain why the polynomial function p of x equals 7 has a degree of 0. So this is the same as writing it p of x is equal to 7x 0. And the reason being is because anything to the power of 0 is equivalent to 1. So therefore, the polynomial has a degree of 0. Okay, explain why this type of function is called a constant function. So the reason is no matter the value of what x is, the value of the polynomial doesn't vary. So p of x is constant. So no matter what the value of x, the value of the polynomial does not vary. Therefore, we call it a constant function. So it doesn't matter what you change that value of x to be, it's always to the power of 0, which is 1. Okay, let's do some quick classifying here of polynomials. So we can classify them based on the number of terms. So monomial, 1 term, binomial, 2, trinomial, 3. 4 or more are just called a polynomial. And then our degree, so we have a constant with a degree 0, linear degree 1, quadratic degree 2, cubic degree 3, quartic 4, etc. Okay, so first one here has a degree of 0, and we call it a constant. Second one here has a degree of 1, which is linear. Then we've got degree 2, which we know is our quadratic. Degree 3, which is cubic. And degree 4, which is quartic. Okay, so it says to research names of degrees 5 through 10, so I'll let you do that. So what does degree 5, what's it called? 6, 7, 8, 9, and 10. So they all have special names associated with them. Okay, so and determining classification based on the types of coefficients. So for example, when we just have integers, it's called an integral polynomial. If I have a fraction in there, it's a rational. And then if we have any square roots, we call it a real polynomial function. Okay, so in each case, write a polynomial. This is pretty subjective, so I want it to trinomial, so 3 terms, quartic, which means degree 4, and integral coefficients. So p of x is equal to x4 minus 2x squared plus 10, right? So trinomial, 3 terms, quartic, degree 4, and integer coefficients. B, we want a binomial, so 2 terms, linear, so that means degree of 1, and real number coefficients. So we could have root 5 x minus 2, right? So 2 terms, linear, and we have a real number in there. And then lastly, a monomial, which is a quadratic and rational. So we need a fraction in there. So 1 over 4 x squared would work. Okay, let's actually get to some new stuff. That was all review. So evaluating unknown terms in a polynomial. So if I'm given polynomial p of x, and p of 1 is equal to negative 9. Determine the value of a. Okay, so they gave it to us in that like function notation. So they're saying if x is 1, so p of 1, it's negative 9. So p of 1 is equal to negative 9. So negative 9 is equal to, and wherever I see an x, I'm going to put in a 1. So 1 squared plus a times 1 plus 8. And then we're just solving for our a. So we've got negative 9 is equal to negative 3 plus a plus 8, which is negative 9 is equal to 5 plus a, or a is equal to negative 14. Right? So again, this is our value of x, and this is essentially our value of y. Okay, number 9, determine the value of a and b in p of x if p of 2 is negative 18 and p of negative 3 is negative 13. So we're going to have to solve for this expression 2 times. So one time making x 2, and then the second time making x negative 3. So let's set this up. So p of 2 is equal to negative 18. So we'll have negative 18, and we're replacing x with 2. So negative 2 times 2 squared plus a times 2 plus b. So we'll have negative 18. 2 squared is 4. 4 times negative 2 is negative 8 plus 2a plus b. And let's just leave a and b on the right. So let's add the 8. So we have negative 10 is equal to 2a plus b. Okay, so that's the first one. Let's do the second one. So same equation. This time we're going p of negative 3 is negative 13. So we're replacing x this time with negative 3. So negative 2 times negative 3 squared plus a times negative 3 plus b. So negative 13, negative 3 squared is 9. 9 times negative 2 is negative 18 minus 3a plus b. And again, let's just add that 18 to the other side, which makes this equal to, if I add the 18, well, 5 is negative 3a plus b. So what you notice here is we're left with 2 equations, both with a variable a and b. So we have our equation 1, and we are of equation 2. So we're going to think about systems like we would have done in 10C, and we're going to, I would solve this by elimination, and we can eliminate those b's with what we have here. So I'm going to go negative 10 is equal to 2a plus b, and line it up with my second one. 5 is equal to negative 3a plus b. And I can subtract these 2 equations from one another to eliminate b. So negative 10 minus 5 is negative 15. 2 minus negative 3 is 5a. And our b's cancel out, and we solve for a. So a is negative 3. Okay, so that's good for our first one. And then we can just take that value of a, plug it back into equation 1 or equation 2 to solve for our b. So I'm going to put it in 1. So negative 10 is 2 times negative 3 plus b. Negative 10 is equal to negative 6 plus b. So b is negative 4. So set up your 2 equations and then use elimination to solve for the variable there. Okay, so that is lesson 1. So the first few questions are just review, so classifying and identifying polynomials, and then you get into solving later into the lesson.